Hey guys, today we're going to look at solving quadratic equations in two scenarios. So the first scenario is when a equals 1, and we worked on factoring quadratics previously, and so we're going to use that skill in order to actually solve them. So when we solve quadratics, you could be looking for a couple of different phrases. So they might phrase it as finding the x-intercepts, or they could call them the roots, or they could call them the solutions. Oops. And so when you're solving a quadratic, you're looking for the x-intercepts, roots, or solutions of that quadratic. And to do this, what we utilize is called the zero product property. So it's basically, if you have any two numbers multiply together and you get 0, then that means that one of your numbers has to be 0, right? There's no way for me to multiply like 2 and 2 and get 0. The only way you multiply two numbers to get 0 means that either A has to equal 0 or B has to equal 0. And so once we get factors from our quadratics, what we do is we set them individually, set our factors individually equal to 0 to find our x-intercepts. Okay, and so to do this, when you have to solve a quadratic equation, first you have to make sure your quadratic is set equal to 0. So we'll do negative 2x squared minus 14x minus 20. We set it equal to 0. And then your first step after you make sure it's set equal to 0 is to factor out your GCF if there is one. So I think I can pull a negative 2 out of all of these. So I'll have, and then to figure out what's left over, remember that we do division, so we can kind of treat it as dividing everything by negative 2. Okay, it's important that I pulled out the negative as well, because you want your x squared term to be positive as much as possible. So by dividing by or getting rid of that negative 2, I've made my x squared term positive. Okay, so then now we have negative 14 divided by negative 2, which is a positive 7x. And then I have negative 20 divided by negative 2, which is a positive 10. And it's still equal to 0. All I've done is I pulled out the GCF. And now we completely factor our quadratic. So this is where we take into consideration what multiplies to 10 and adds to 7. Again, you can be utilizing this table if you need it. So what multiplies to your AC value and adds to your B value. And for me, I believe that ends up being 2 and 5. Yep. Cool. So when we completely factor, your negative 2 is out front. Then I have an x plus 2, x plus 5 equals to 0. And then, so now we apply our zero product property. So basically it's saying that if this term times this term times this term equals 0, then some of these, like one of these at least, has to equal 0. So we check each piece. So basically you set each factor equal to 0. So x plus 2. Okay. And then we know, well, negative 2 doesn't equal 0, so obviously that one will not be working. So you won't get a solution from that piece at all. But we can get a solution from here by solving for x for each of these. So x equals negative 2 is one solution, or one x-intercept. And then x equals negative 5 is one of our roots, or solutions. Okay. Sometimes when you're doing quadratics, you will run into an issue where the quadratic is not set equal to 0. So to solve, I just have to use our inverse operations. Basically, you're just moving everything so that it all falls on one side of the equation. And I always try to move things so that my x squared or n squared term stays positive. So like I'm going to, since it's already positive on this side, I'm going to move everything so all of my terms will be on the left-hand side of that equation, okay? So in the scenario of x squared minus x equals 6, so this 6 is my problem causer, so I'm going to go ahead and subtract 6 from both sides. So that way I get an x squared minus x, actually, I'm going to write it over here. X squared minus x minus 6. Make sure you're only combining like terms, and so x squareds can't be combined with regular x's, can't be combined with negative 6. All right, is there a GCF is my next step because it's already set equals 0. So now is there a GCF? Nope. So now I'm going to go ahead and factor it. So you're figuring out what multiplies to negative 6 and adds to a negative 1. Well, that would be a negative 3 and a positive 2. So then I get x minus 3 and x plus 2 equals 0. And so then I separately take those factors and set them equal to 0 and solve. Okay, so then plus 3. So x equals 3 is one of my solutions, or one of my roots. And then minus 2, x equals negative 2 is my other one. All right, if you want to go ahead and pause and try those u-tries, feel free. And now I'm going to go through them. Okay, so again, this isn't set equal to 0. That's the first thing that always has to be true. So I'm going to go ahead and subtract 5 from both sides. So then I'll have n squared plus 7n plus 10 equal to 0. I'm figuring out what multiplies to 10 and adds to 7. So that would be 5 and 2, I believe. N plus 5, n plus 2. Oh, I'm sorry. There were no GCFs, so I didn't pull those ones out at all. And then I set my factors separately set equal to 0. N plus 2, n plus 5. So n equals negative 2 is one of my solutions, and n equals negative 5 is another solution. All right, with this last one, go ahead and try it. And now I'm going to do it. So I'll subtract 6, because I need to get set equal to 0 first. So I have x squared plus 3x minus 18 equals 0. No GCF, so now I'm going to go and figure out, because my leading coefficient's 1, I can go and figure out what multiplies to negative 18 and adds to 3. And I believe that would be a positive 6 and a negative 3. Excellent. And then I separately set those factors equal to 0. N plus 6 and minus 3. And I solve for my x-intercepts, aka my solutions, aka my roots. Awesome. And so that's dealing with specifically problems where your a value is equal to 1. You'll notice for all of these terms and all these problems I tried, after I factored out any GCFs, there was always just a 1 in front of my x squared. So like there was a 1 here, 1 here, 1 here, and 1 here. If there isn't a 1 there, then we have to use a different strategy. Okay. All right, in this next piece, we're solving using a difference of squares. So sometimes we run into this type of quadratic equation where you have just an x squared term and a constant, and it's got subtraction. It's called the difference of squares because the first term is being squared and the second term is going to be some sort of perfect square number. So for example, like a perfect square number, 1 times 1 is 1. So that's a perfect square number. 2 times 2 is 4. That's a perfect square. 3 times 3, 4 times 4, 5 times 5, and so on and so forth. So anytime you see these types of numbers, what was that, 7, 8, 9, 10, I believe it's in there, 11, 12, 13, 14, and obviously you can keep going, boop, boop. Okay, so anytime you see these numbers and it's just an x squared term and a constant, you're probably going to be using a difference of squares. So it's got 2 pieces, one's an x squared, one's a constant, and you're going to go from there. To solve these specific equations, we factor our quadratic into x minus m and x plus m. And I'm going to go ahead and we're actually going to adjust some of these because there's some of them that I want to cross off. So cross off this one, cross off this one, and then last piece. Okay, that's good. All right, so we're just gonna work on these 4 actually. So in this first example, I'm going to go ahead and do it. So first, you have to make sure your quadratic is set equal to 0. So I'm going to go ahead and subtract 16 from both sides. So then I have x squared minus 16 equals 0. And I notice, hey, I have just an x squared term and a constant. And then if I looked at some of my perfect square numbers, 16 is one of those constants, one of those perfect squares, okay? And so what I know is I can break this up into x minus m and x plus m, where m is the square root of your perfect square. Now that sounds a little bit complicated, so another way we kind of like to write it is like this. So basically in this scenario, I have something squared minus something else squared. And so what that translates to is that if you're trying to find the solutions for that, it factors out into x plus your second term squared and x minus. Right? So that's a difference of squares. You take the square root of each of those pieces. So like square root of x squared is just an x. Square root of 16 is 4. And you make one of them positive and one of them negative. And then that's how you get your difference of squares. And so then your solutions for that would be if you had, you set them separately equal to 0. And then your actual final answers at the end would be -4 and +4. Okay, so anytime you have difference of squares, you can use that. All right, this one's already set equal to 0, but I do notice I have a GCF. 2 goes into both 2 and -98, so I'm going to go ahead and pull out that 2 first. So then I have 2, and again, you're thinking of it as dividing by 2 to figure out what's left over. I need a little more room. So then I'll have 2 parentheses, x squared minus 49. Okay, and then I notice I have an x squared and just a constant, so I check and I'm like, hey, that constant is one of my perfect squares, it's 49, and so if I was going to rewrite it, this is really x squared minus 7 squared, right? So then when I factor this all the way, I have my x plus 7 and x minus 7. And then don't forget you also have that 2 out front. So that's fully factored. And then again, you set all of your factors equal to 0 and solve separately. 2 can't equal 0. And when I set x plus 7 and x minus 7 equal to 0 separately, I get, these 2 answers or roots or solutions. So -7, +7. Cool. So go ahead if you want to pause and try this one, feel free. And now I'm going to work through it. All right, so when you solve quadratics, we get them each side equal to 0, so I'll subtract 21 from both sides. Okay, so then we have x squared minus 12 minus 21 is 9. Okay, no GCF. And so then I have an x squared term and just a constant, so I check and make sure 9 is a perfect square. So this really looks like, x squared minus 3 squared. So then it breaks down into x plus 3, x minus 3. And so then your solutions would be x equals -3 and +3. All right, last one. So for this one, I could, gotta get it set equal to 0, so I'll subtract 140 from both sides, and then I'll have 3x squared minus 147 equals 0. And then I have a GCF, I can pull out that 3. And then to figure out what's left over, we think of it as division. Divided by 3, divided by 3. And I get just an x squared minus 49. And then my x squared piece right there is just an x squared and a constant. So I have something squared minus 7 squared. Oh, it looks like kind of like this one. And so then this breaks down into, I'm going to write over in this space, 3, and then x plus 7, x minus 7. Again, separately set your factors equal to 0 and solve. 3 can't be 0, but if x was -7, it would work, or +7. All right, so that's some difference of squares problems for you. Let me know if you have any questions. Other than that, feel free to go practice.